My name is Yuval. I'm a VP product here at DriveNets. I'll walk you through service marketplace evolution. Ran spoke a little bit about how we build the marketplace, what kind of services you can have there, and what can we run on top of the cluster, whether it's third-party service instances, whether it's DriveNet own third-party. So I'm going to elaborate a little bit how do we really build that marketplace and what's our plan to do that. Okay, so as always, feel free to ask questions in the middle and stop me when you want to. Okay, so let's talk a little bit about the marketplace evolution. Essentially, there's three main sources where we will actually add services into the marketplace, types of services we can have. First of all, definitely we're starting with DriveNet's homegrown services, right? We have network-centric services. We spoke a little bit, Dudi spoke a little bit about it earlier, whether it's core edge applications and services like maybe NAT, IPsec, all kinds of functions which are more network-centric, and we're utilizing the hardware and the chip that we support to run it in our cluster. So we're adding those as what we say separated service instances, right? Each one of them is a service by itself, and they can all run on the same infrastructure. So if you have core and edge and they run on the same cluster, they can run as different functions. So those are definitely what we call the default. Whatever we develop at home, we can run on top of our infrastructure. Now the second bullet, and it was mentioned a little bit, obviously important, is that it's orchestrated by Dino, right? Our orchestration system is not only managing the life cycle of the product, the cluster itself, whether it's the hypervisor or the hardware, like deployment, upgrade. If you think about it, a DDC cluster, we support up to 200 tera. So it's almost 70 nodes within a cluster. Think about what does it mean to upgrade a cluster in less than 4 hours during a maintenance window, right? Those are strict limitations by service providers. So Dino helps us to do that. And in addition, you have all the services that you can run on top. So it's not just a lifecycle management of the hardware. It also supports the different types of services, connecting them together within internal links, the ISLs we mentioned, and making sure there is a service on that infrastructure that runs end to end. Okay, now keep in mind, it's within the infrastructure. Okay, we're not talking about a network-wide orchestration that connects all kinds of services together, but essentially it's making sure that those specific instances run on the infrastructure and they actually connect to each other to look like a normal small network on the DDC. Now that's source number one, right? DriveNet's homegrown. The second one, and that's important, what we call open third-party services. So service provider are trying to be innovative, and they have to have their own uniqueness, right? They want to develop their own applications or services and offer to customers, like optimizing all kinds of working from home services, right? When they offer last mile services to customers, and they optimize the services they have compared to to their competitors. So they're trying to be innovative. They're trying to add more flavors into their catalog so they can offer to customers. And this is where we're saying you can use our infrastructure. Now think about it. You deployed our cluster in your network, in one of your COs, right? At day one, you install there a core or an edge function, which is pretty similar to what you have just by a vendor named DriveNets. Now, in a month from now, you want to add more services into the same CO. Now, one of you mentioned earlier, today you add another server or you add another rack and you have more appliances and you have to bind everything together to make it work. Now, when you have the infrastructure already in place, just install another service instance, logical software, okay, a virtual component being added on top of the existing infrastructure, and that's it, in a click of a button. So all you have to do is certify even your own homegrown application, add it to our Dino, right? Define the flavor of it, how much resources you need. Sometimes it will be a small amount of routes from the TCAM. Sometimes it can be all kinds of complex QS or ACL functions. You need a specific API for that. All you have to define is the scale of the application, the number of resources that you need, click a button, and then you connect it to existing infrastructure that you have on point. So that's a way for the service provider to kind of, be up to speed with the market, try to innovate and compete with their other operators in the network. Now, the key point here is the integration to the Network Cloud API. I'm going to cover it a little bit in the next 2 slides. On top of the hypervisor, there's an API. Now, when we first started developing network cloud, so naturally we use the SDK on top of the chip vendor, on top of Broadcom, to integrate to the hardware and to integrate to the chip. Now, if you take that development, essentially all you have to do, or we have to do, is expose it so you can use it as an application developer, right? If I have my own DNOS with my own core function that all it has to do is install routes on the chip, so it's a basic API of unicast and multicast routing. So we're going to expose that in our network cloud API, and you can use it in your own application. Okay, so once you have that layer, just take a look at the API catalog, see what you can use. You can ask for additional APIs that we can add into the catalog, and everyone can actually use it. So that's how you develop the API catalog as well, on top of the services. Now, bullet number 3 is, and I think Ran mentioned it earlier, is really using third-party services from leading vendors in the industry. Again, we don't want to be the leading DDoS vendor, but we want to work with them. So we have a lot of, I would say we're working on partnership with some of the vendors in the industry, getting them on board and integrating with our solution. And I can tell you that customers are doing the same. When they're buying our product, they're using the infrastructure. And in their mind, they're saying, I'm buying it today because I want to use the core or the edge function, but it's an infrastructure. So I'm going to talk to my own firewall or my DDoS provider, who now runs on a virtual appliance on my data center, and I'm going to put it in the network. So instead of having a centralized DDoS solution, I'm going to have a distributed one across all over my COs in the network. So it makes more sense to them from OpEx and CapEx perspective to use DriveNets as an infrastructure and all kinds of routing and network services, and using their existing vendors to integrate with us. And we're open to that, right? Because we have an API, we're going to work with them. And this is how you build the ecosystem, and this is how you develop or evolve the services marketplace. Okay, so that's the first slide. The second one, I'm going to talk a little bit about the architecture that really allows us to do all of those different functions. Take a look at the bottom. Obviously, there's the hardware section. It doesn't really change. It doesn't matter if it's a Broadcom Jericho 2, some other vendor chip, or different types of ODMs using the hardware. From our perspective, there's an API layer that really abstracts that. If we want to add an additional hardware or different chip vendor, we can do that. It's not a matter of months or years to develop that. All we have to do is make sure that the APIs are integrated, do the testing, and then we have another hardware, another ODM that we can work with. Okay, so in terms of the hardware, it's agnostic to the type of service you want to run on top. Now, on top of that, there's definitely the hypervisor that's responsible for all the resource allocation throughout the hardware and the chips. And the most important part I want to talk about is the API, because you can have different types of services from different sources, right? We mentioned DriveNets, open, and third party. Now, all of them need to use really the same API, okay? Otherwise, we're going to have to develop something which is unique or proprietary to each one of them, and this is not the goal, right? Our goal is to use a unified architecture for any type of service you want to run on top of the DDC, on top of our solution, okay? So we're going to elaborate a little bit about the API. You can see on top the different type of services. Each one of them can have their own northbound interfaces naturally. I mean, I can use SNMP in my application. Some vendor wants to use gRPC, the other one wants to use netconf. It's okay. I mean, it's really agnostic to us. Everyone with his own service instance or service brings his own capabilities for northbound interfaces. And I think most importantly, everyone is still using the same orchestration layer. So Dino really enables service configuration and management for any type of service instance. If you think about it, just like in the cloud, it doesn't matter to you the type of application you're running on the server. The orchestrator just looks at everything as a container. It's being wrapped. There's different flavors you can add to it, different configurations like NIF, resources, QS, ACL, different type of configurations you can, or flavors you can modify on that specific instance, and that's it. It doesn't matter what type of application or you have within that service or service instance, okay? So it's the same architecture for everything.
Could you maybe go into more detail about how that actual integration works between the orchestrator and other network elements? Because I think that's probably the hardest part about any orchestration platform is how do you actually interface with the devices. And I heard you mention SNP. I'm assuming V3 for right there, netconf, gRPC, CLI, is that an option? And then the other question is, who develops those I guess, drivers that connect to those third-party devices? Is that something DriveNets develops? Is that something that the customer develops and DriveNets just provides a framework? Maybe just like some color on that is what I'm looking for.
Okay, yeah. If I try to maybe frame it, I think you're asking about Dino as an orchestrator in a network where you have network cloud and third-party other, let's say, competing vendors or the incumbent vendors that they have their own, I would say, routers or their own chassis in the network. So it's a different angle than what we're talking about. But I would say in general, Dino supports all the standard southbound and northbound API. So southbound netconf, gRPC, and restconf. SNMP and syslog is essentially not related to the orchestration itself. It's a way for the routers or devices in the field to, extract, send out alarms onto specific syslog servers and SNMP servers. So from orchestration perspective, if we want to manage DriveNets or other devices, we would use the standard netconf and gRPC. And there's no specific APIs for that from DriveNets from DriveNets perspective. We developed APIs to do the upgrade and deployment of the cluster because it's a unique solution, the DDC. If you're talking about other vendors, incumbent vendors, they would have to build their own APIs to make sure we integrate with them, as they would do, I think, with any orchestration system in any service provider network, right? I mean, if you're a service provider, and we all know that's one of the major challenges, you have a lot of vendors in your network and you want to make sure they work together. So you need to work with them to make sure they all have the same, at least the baseline. At least all of you should work with gRPC and netconf. And after that, each vendor usually provides its own APIs because it's a different types of configuration, different types of models in terms of how it works. But other than that, Dino supports pretty much the native one. netconf, gRPC, OpenConfig.
Yeah, thank you. And then does the Dino orchestrator, does it model services? Kind of maybe you model your intent in the orchestrator, and then the orchestrator handles pushing that out over those APIs. Is there some sort of abstraction of your services that you define inside of the orchestrator?
It's a good question because I think we need to define maybe the difference between a network-wide orchestrator, which is a different layer of usually OSS that service provider has, which control network-wide services end-to-end. Like when you want to deploy, I think someone mentioned earlier, you want to deploy layer 2 VPN service across the network and you have multiple vendors. It's a different type of orchestration because it's an end-to-end service orchestration. Now that's a different type of service that we're talking than the one we're talking here. When we're talking about the service within Dino, maybe I'll go back a little bit. You can see that each, I would say, cube here on the right side of the screen, it doesn't represent an end-to-end service across the network. It represents a service instance. Okay, think about it like a VM that you have today that's installed on the infrastructure. The VM doesn't really talk about end-to-end connectivity. It talks about a specific virtual function on the infrastructure. So a service here means I installed a virtual function on the infrastructure. I took some of the resources to run that function, namely a router that does edge or a router that does core or virtual firewall. Internally within the infrastructure, not externally in the network, but within the cluster, we're doing the connectivity with ISLs using the Dino. But if you take a look back and take a look at the cluster, it looks like a small network that connects to other third parties. And the integration to those other third parties, like incumbent vendors, it's done using the existing orchestration system of the service provider. So it's a different layer. We're talking about managing the infrastructure.
Okay, so this is more of a, you would run it as an island that you're orchestrating basically just the DriveNets portion of your network, and then you would need another orchestrator on top of this to actually do end-to-end stuff, would be maybe a way to summarize that.
Exactly. It doesn't really tackle the orchestration layer across the network where you have more complex layers, essentially like in the NFV world where you have different types of layers in the orchestration. Here we're talking about the island of the DriveNets infrastructure, but you can still have there a lot of third parties, right? If you think about it, I'm selling VPN to customers. If I'm a service provider and I'm selling business VPN to customers, I would usually install it on generic routers in the network, right? But my firewall will actually be sitting in the data center behind the core, behind one of the COs. In our case, you don't have to do it. You can install a small virtual firewall immediately in the network at the same location where you have your VPN terminated, and then essentially you have a distributed firewall across your network. So it's a different way to take the services and applications you will install in data center and put them inside the network. But again, it's on the specific location of the infrastructure, okay? DNO sees the network, right? We obviously integrate and we can see the topology and we can read links like every other orchestration system does, but we don't manage the service really end-to-end on other third parties. It's a different type of use case. I mean, customers usually speak to us about it and ask about it, but the main goal is to talk about the orchestration of the infrastructure.
I have seen implementations in which what they are using to do exactly what it is Openstack. So is it fair to say that it has similarities between Openstack and what you guys are offering right now? What does it make different? In many cases, I have seen that Openstack is also used to orchestrate all the infrastructure and even some services, and everything happens within a particular device that it is completely isolated from the rest of the network. So each one of those is a small island where the world is built. It's like having these small spheres that you get for Christmas. So everything is just built within it.
Right, exactly. We're not using OpenStack in that case, but I would say the concept is similar. You look in a specific vertical where you have your infrastructure installed and you're managing the resources within that. As a system, we do see all of those islands and we know to do, correlation between them, read alarms and try to do the analysis on top of that. But we're not really running a full network blown orchestration like you do in OpenStack.
Want to get a little clarification. So once you assign the resources with the orchestrator, then you have to go into another piece of software to actually configure that for the service that you assign the resource for. Is that accurate?
Configure the resources? No, well, essentially, let's say I bring up a service that is a core function, okay? And I configure the flavor of the core to be, I need 10 ports of 100 gig because those are my uplinks. I don't need a lot of TCAM because there's not a lot of services in core, but I need a lot of bandwidth. So I just define the scale that I need in terms of usually interfaces and maybe some TCAM, QoS, counters, etc. And I deploy it. Once you deploy it on the cluster, the hypervisor reduces the amount of resources from the one, allocates really the resources from what we have on the chip or the hardware. And if you don't need to configure any more resources or anything to activate them, but essentially you log into the service instance, which looks like a router from your perspective, and you just start configuring the interfaces. From your perspective, think about it like you are installing a VM and you assign network interfaces to it. Once you assigned it using the hypervisor, when you log into that VM, you are in your own world. You have your own NIFs, you have your own compute resources, your own disk space, and from that point on, it doesn't matter to you, you're running on virtualized environment or not. So it's the same thing. Instead of logging into a physical router, it looks to you like a physical one, you just happen to be installed as a virtual one on a cluster. So it looks the same to you.
Given how you've talked about how the interactions happen within the cluster and how they configure network elements and things like that, do you have any requirements of what connectivity that uses internally? So if, let's say I have a mandate that says I'm not allowed to have IPv4 running, can you operate in the total absence of IPv4? Can you do provisioning on remote things, over IPv6?
So the ISLs that we have internally, the internal links, they have the same functionality, and that's important, exactly same functionality like a network interface, which means I can run IPv4, I can run IPv6, I can run MPLS, I can run each one indifferently with or each other, exactly like a normal NIF. So if I have an IPv6 native network without IPv4 and I want to run core and edge functions and bind them together on the same cluster, easy like a normal router would do on two virtual interfaces, instances. So it's the same thing. There's no limitation there. It looks like a normal NIF interface, network interface.
That's wonderful to hear. So basically you're deferring to what's available on the host system and just relying on the stack and not making any sort of false requirements that this has to have IPv4 as a...
Exactly. Exactly. We're really using, if you think about it, the implementation of the ISL is using the internal architecture of the chip that we have. So essentially, there's no reason why it shouldn't act and behave like a normal network interface. So why limit ourselves? You can do whatever you do on a normal router. You don't even know it's virtualized. That's the whole point. if we would start limiting users from using V4 or V6, they would just say, okay, so it doesn't really work now. It doesn't work for 2023. It works for 2022. We need it for later on. There's no point in doing that. You want to have from day one to have all the capabilities you have in a normal service that does routing, virtual firewall, etc. You'll have it all from day one. Okay, so moving on, I spoke a little bit about the APIs, and basically it's going to use the same layer, but let's dig a little deep into it. What does it really mean to have network cloud API? So essentially, I'm dividing it, let's say, as an example, right? There's definitely a lot of more APIs in our catalog and in our architecture, but as an example, you have different types of APIs. And if you think about it, think about what happens when you develop a simple router from day one. You would have to have an API that does unicast and multicast routing installation for the feed, right? It's pretty generic. You would need sub 50 millisecond FRR because that's path protection, because that's what service provider requires today. If you're talking about security, you'd have to have ACL, static or dynamic ACL, like in BGP flow spec, and you would have to have quality of service. I mean, those are generic features, right? But what's the key point here? We took the features and the APIs that we already developed in the past few years, and we just exposed them to be outbound facing APIs for anyone who wants to connect on top of our hypervisors. So we just made our infrastructure an exposed one, right? So we took every API we developed for the past few years and just expose them in an API catalog where we explain, and you know how it works. You explain exactly the API, the parameters, the scale, and essentially when you bring your own application or service or even a third-party one, which is a known vendor in the industry, all he has to do is integrate on top of that API, same as we do today, and that's it, plug and play. Okay, and we do the same for our internal developments. We don't use proprietary APIs just specifically for DriveNets because we want to test the APIs we provide to integrators or customers, right? So we're using the same API. Whatever we develop in-house, we expose it and you can use it externally. So let's take an example here. You see a lot of APIs being mentioned here. How would you actually use it in one of the applications? So I think one of the examples we showed earlier is either multiple routing functions on the same cluster, or maybe let's take another example of peering and DDoS, okay? You can have a peering application in your network, right? Now, we all know that usually there's DDoS in service provider network to protect, obviously, their infrastructure, to protect their routers from DDoS attacks, but usually it's a centralized solution sitting in the data center, and I guess you all know you're sending net flow samples out to the collector, he sends mitigation back using BGP. It's a long delay. It takes time to do the mitigation and on and on. Now, we know the solution isn't perfect. There are ways to do distributed DDoS. How would you implement that on our system or our architecture? Take a look at the slide a little bit on the left side. At the bottom section, I think someone mentioned it earlier, that's the data path, okay, on the NCP. Okay, there's a lot of different engines or processes that really runs on top of the data path where the white box agent really sits. And you see at the bottom, obviously, the SDK and the BSP that connects to the hardware. But there's different types of engines that or processes we're using there or we have implemented to run our basic services, right? Core, edge, any other function that we have today. On the top, example for two services, right? Two service instances. One of them is DriveNets, homegrown DNOS routing size for peering. The other one, third-party vendor, okay, there's a vendor we actually integrated with. I can't really state the name, but we already integrated with several vendors for that solution. And obviously they have their own databases, mitigation processes, they have their detection mechanism. And what they need from us is really an API to do the detection and mitigation locally on the infrastructure. They don't want to do it on a remote mitigation center. They want to do it physically on the infrastructure on site. So what we have in the middle is the network cloud API. Let's start from the routing. That's pretty basic. I have peering, a BGP peer that I want to connect to. I need to have BGP session running up. So I have to have interfaces with IP addresses. So that's the first one, right? Network interface API, I just name the interface, I name IP addresses, and I connect actually to the chip and hardware to configure that. And after that, I configure BGP and I start inserting routes into the feed, right? That's pretty simple. I use unicast routing table API to install it into the chip. Now, what's the fancy part about the DDoS section? We provide APIs for NetFlow to do the sampling, but it's locally. We're not sending it externally out of the system. We're sending it to the local service that's sitting on our infrastructure. It's not even sitting in the DNO. It's physically on the NCC, on the controller, locally within the architecture. He gets the polling, right? He does the detection. He sees there's a faulty flow. Now he needs to install an ACL. So we support dynamic ACL, same as in BlueJeep flow spec, right? So we install it dynamically on the chip in real time. It doesn't have to wait for the sampling. It does it in real time. We install it on the chip. And from that moment on, he has to monitor using the NetFlow if he solved the problem, right? And there's no more issue with one of the flows. And obviously, he has to measure counters as an example, right? To measure the performance of the interfaces where he actually does the mitigation and the detection. So everything runs locally on the same architecture, on the same cluster, using the Network Cloud API. So everything that was used to be done using external interfaces, NetFlow to an external system, or if it's BGP flow spec to insert the ACL rules, there's no need to do it anymore. You do it internally using just an API, okay? And everything is being done live. So in this example, detection using NetFlow, mitigation using dynamic ACL, telemetry using internal channels. It could be protobuf, it could be gRPC. Everything is local, so you can use every protocol that we support. And lastly, obviously, counters, you read them directly from the chip. There's no need to wait for the counters to come to you in some sampling method. So once you do that, everything is locally, the mitigation is live, the scale is much higher because you accelerate the number of flows and ACL that the DDoS vendor can support using the hardware. If you think about it, one of the limitations that every application provider has, it's scale, right? He needs to have a lot of rules in his system. Now, once he does it in a remote server, he's limited in the number of flows he has to read from the entire network. Over here, he doesn't have to. He has a very small service instance that's used only for the local cluster, and all he has to do is support the local scale. So if you think in terms of the provider or the vendor of the application, there's no limitation from his perspective. He can distribute those small instances across the network and use our chip to do the offloading, okay? So this is a very brief example of how you use different network cloud APIs to really answer a small, very specific solution for peering plus distributed DDoS.
If I understood right, you're using somebody else for the detection of whoever one of the providers out there is for DDoS detection, and they're using this for distributed scrubbing at the local level. So if I'm a regional provider, I've got a dozen data centers. This is something I would put in the data centers so that the flow spec rules and the detection and mitigation can be pushed down to where my transit peers are and where this is happening. Is that fair? Is that the architecture you're describing? Because what I'm struggling to understand is, does this sit in between the peering edge, or is the peering edge?
It is the peering edge. I think you mentioned earlier what you do in terms of data center versus the network. So I'll go back to what I mentioned earlier. When the world first started, DriveNet developed the DDC cluster, the infrastructure, and ran a single application, core routing application. Now, as time went by, we obviously added more and more features, but the key difference, we're developing it in separated containers and service instances, which means you're still running in the network. You have different types of services separated, but can run on the same box. I'm just adding another type of container, which is not networking by DriveNets on the same infrastructure in the network. The whole point is to not do it in the data center. Two reasons for that. One, you're investing in specific servers and hardware and appliances just for that use case, right? If you take DDoS, there's an appliance for mitigation of DDoS you need to buy for one vendor and put it in the data center. That's one. The second one, scale. It has to talk to those 12 POP or edges that you have in your network and get the collection of all of those flows into the data center. So it's a whole huge pipe of traffic that needs to run towards the data center, right? That's number two. And number three, you, instead of using it as a centralized solution, you can use it as distributed in the network. There's no need for the data center anymore for those use cases.
The reason I ask is how it's used outside of the data center is a bit unclear to me as we get into the aggregation layer, the transport layer, the last mile, because it wasn't clear to me exactly where this physically sits as you have this, these distributed white box switches and then the software that sits on top. So, if I were, I don't know if you've used this in a telco, but like in a telco, for example, would this be at the CO level, the RT level? Is this in a cabinet on the side of the road? Like where does DriveNets end, I guess is the question.
So if you take a look at the telco, we're not specifically talking about like telco edge specific cases. Think about it, every location in your network, you would install a router today, and you would also install, or where you install a router today, you can install our product to begin with. You can install the infrastructure. It can even run just the basic service instance of core edge VPN aggregation, right? It's one for one, rip and replace. Take the old chassis incumbent vendor, install a new disaggregated vendor by DriveNets, right? That's one for one. But what's the next phase? In every one of those locations, and I mean everywhere, if it's the core where you have a large cluster, or last mile where we have a small standalone box, you can run on top those virtualized instances. So if you think about it, your entire network becomes a distributed data center, but for networking, right? We don't want to take the huge storage that you have in each data center and start spreading them out in the network. It doesn't make sense financially. But what we do want to take is those applications that need acceleration and are better off being distributed than centralized, and spread them out to the network. That's the whole point. Okay, so
got it. So this isn't intended to replace the BNG or the PE or the ONT, OLT. This is a piece that integrates with them to distribute services.
No, so take in the row that you mentioned, from OLT, ONT, BNG, stop at the PE level. You have a provider edge router there, right? Does a lot of sessions, a lot of QoS sessions, and has a lot of interfaces, right? Take it out, put DriveNets cluster there, assuming you need a large bandwidth for a standalone, that's fine. It does the same function. Same function as the PE, provider edge, but now you have the benefit of adding third-party services on top of it. You want to add your BNG specific virtual provider, right? You might have an application. There's several vendors out there today. You can use that on top.
So basically, if I want to use a VBNG from a specific provider that I like, I'm going to put your box in, and then I'm going to take my BNG functionality or whatever it is that I'm using, and this is a way to distribute those applications and services out on a common control and forwarding plane.
Spot on, exactly.
Got
you have the combination of our provider edge and your favorite vendor for VBNG, virtual firewall, DDoS. Bring your own vendor,